Hello and welcome to another Ginger Mathematician video where I'm going to go through everything that you need for the 0580 IGCSE course on differentiation. So I'm going to start with some paper 2 questions. Now it doesn't come up quite often on paper 2, but it is worth going through a couple of questions towards the end of the paper where it does appear. And before I get started, then please do think about liking and subscribing. It goes a long way for helping the channel grow and making me happy as well at the same time. Right, let's do some paper 2 questions. Okay, so let's go through some typical paper 2 questions, and all these questions that you see today come from the last 3 years of papers. So find the x-coordinates of the point, note the coordinates, of the points on the graph of y equals x to the power of 5 minus 5x to the power of 4, where the gradient is 0. So you usually give some indication of either a turning point or where the gradient is 0. So this is the thing to look out for when looking for a differentiation question. So what we're going to do is we're going to take our function and we're going to work out the derivative, dy by dx. Now the process that we do here to do this is we take the 5, we bring it to the front. So I'm going to bring the 5 to the front, and now we reduce the index by 1. So what do I mean by this? Well, we're going to reduce this from a 5 to a 4. And this is the standard process for differentiating at IGCSE. This one here, well, we're going to take the 4, we're going to bring it to the front. So what does that mean here? Well, we need to do 5 times 4, and that's equal to 20. And then we reduce the index by 1. So we get x to the power of 3. Now in the question we want to find out where the gradient is 0. Notice dy by dx, this is what's called the gradient function. So we want to take the answer we just made and make it equal to 0. So we need to solve this equation here. Now this is actually an equation which we can put into a single bracket. So what do these two things have in common? Well, they have a 5 in common and they have an x cubed in common. Because notice x times x times x also fits into this as well. Then we open up our brackets. We say to ourselves, well, what do we multiply 5x cubed by to get 5x to the power of 4? Just x. What do we multiply 5x cubed by to get minus 20x cubed? Well, that's just minus 4. And now we use the null law. So either this has to be equal to 0 or this has to be equal to 0. Because you have two numbers or two things that multiply to give you 0, then one has to be 0. So either, this is the way I like to write it, either 5x cubed is equal to 0, which means that x then has to be 0. It's the only thing that works. Or x minus 4 is equal to 0, and therefore we solve the equation x is equal to 4. And notice all they wanted for this question are the x coordinates. We don't need to work out the y coordinates in this case. So our answers here are x is equal to 0 and x is equal to 4. So we write that in. However, in our next question we're going to look at on a paper 2, they sometimes ask you for the actual coordinate itself. Let's look at that now. So we want to differentiate 6 plus 4x minus x squared. So we need to differentiate this function. So let's go through that process now. Now if you have a number and differentiate it, it disappears. Okay, so we're going to ignore that. If we differentiate this, well, we still use the power law as normal. Notice x on its own is the same as x to the power of 1. So we bring that 1 and bring it to the back. 1 times 4 is 4. Reduce the index by 1, so x to the power of 0. Now some of you already know what the answer is, but I'm just going to write it out in full. And if we differentiate the minus x squared, well, the 2 comes to the back. So we get minus 2. And then we reduce the index by 1. Well, let's reduce that down from 2 to 1. Now at the moment it's in kind of ugly algebra, so let's tidy this up. So remember, anything to the power of 0 is equal to 1. 1 times 4 is 4. And remember, x to the power of 1, we generally like to write that as x. So our answer for this question here is 4 minus 2x, like so. And now we need to work out the coordinates of the turning point. So that's when the gradient is equal to 0. Kind of the other way around to the previous question of this function here. So we want to set our gradient function, 4 minus 2x, our dy by dx from the previous question, equal to 0. So this is a straightforward equation to solve. I'm going to minus 4 on both sides of the equation. This cancels. We get minus 2x is equal to minus 4. And if we divide by minus 2 on both sides of the equation, this cancels and we're left with x is equal to 2. Now notice that's not our final answer. That is just the x-coordinate of the turning point. To work out the y-coordinate, we need to sub x equals 2 into here. So we need to then do y is equal to 6 plus 4 lots of 2 minus 2 squared. And if we work that out, well, 6 plus 8 minus 4. Remember your bid mass. 6 plus 8 is 14. 14 minus 4, well, that's equal to 10. So our final answer for this question is then 210. So you need both the x-coordinate but also the y-coordinate there as well. And you can have a look at the mark scheme. This is where you pick up your method marks if you go a little bit wrong right at the end. But generally speaking, differentiation appears on a paper 4, and it's often integrated into other topics as well. You'll find it, of course, towards the end of the paper, but they often have a separate part of a different topic first, and then they put in the differentiation afterwards. And I've got lots and lots of examples to go through today where we see exactly what context they bring differentiation into. Okay, and on to some very typical paper 4 questions. And so we're going to look at this one here. As you can see, it's out of 8 marks, so it's going to take a little bit more work. So first of all, we want to work out dy by dx of this function here. So the way we do that is just like we did on the paper 2 questions. So we take the 3 here, we bring it to the back. So 3 times 2 is equal to 6. We reduce the index by 1, so it was an x cubed, and now it's going to become an x squared. And likewise for this part here, we're going to take the 2 there, we're going to bring it to the back. Minus 4 times 2 is equal to minus 8. We reduce the index by 1, so this becomes x to the power of 1, or as we like to write, just x. And that's all we need for our derived function. Remember, if you differentiate the 6, then the gradient of that is 0, so that will disappear. And now this is very typical on the part 2. We want to work out the gradient at a specific point. So we want to work out the gradient when x is equal to 4. So we take our initial answer here, so 6x squared minus 8x, and replace the x with 4. So we get 6 lots of 4 squared minus 8 times 4. And remember our bid mass, so 4 squared is equal to 16. 8 times 4 here is equal to 32. And now we just need to do this calculation here, so 16 times 6. Now, again, we've got a calculator, but again, you can always do it manually this way as well. This gives you 96. So then 96 minus 32. Again, any of this can be done on your calculator as well. And this gives you the final answer of 64. So the gradient at that particular point is equal to 64. And this is a good question to go through because it goes through a lot of the typical kind of paper 4 style differentiation questions. And we want to work out the coordinates of the 2 stationary points on the curve. So as soon as you see the phrase stationary point or turning point, you need to be thinking that the gradient function, that's a T, gradient function is equal to 0. Well, what does that mean? So we take our initial function here, our 6x squared minus 8x, and make it equal to 0. So you need to have good quadratic skills as well in order to be able to do these questions. Now here, this is an example of where we factorize into a single bracket. So what do these two things have in common? Well, they've certainly got a 2 in common, and they have an x in common as well. So then we open up our bracket. What do we multiply 2x by to get 6x squared? Well, that's going to be 3. 3 times 2 is 6, and an x. What do we multiply 2x by to get minus 8x? That's going to be minus 4 is equal to 0. And just like we did in one of the paper 2 questions, we use our null law. So when 2x is equal to 0, so we know one of these things has to be 0, we don't know which one. Well, x is equal to 0, and when 3x minus 4 is equal to 0, well, 3x is equal to 4, x is equal, oh no, so near the bottom of the page, is equal to 4. It doesn't want me to write it, I'm going to write it over here. See, there we are, 4/3. That is going to be 4/3. There we are, I'm determined to write it. There we are, so x is equal to 4/3. So that's our x coordinates of the turning points, so 0 and 4/3. And now we need to work out the y. So we need to take our function right up here. So this is equal to y equals 2x cubed minus 4x squared plus 6. And now we need to replace the x in here with these values of 0 and 4/3. So let's start with 0. So when x is equal to 0, y is equal to, well, that disappears. That's cool. This also disappears. That's even cooler. And we've got the plus 6. So these all disappear, and we're left with just 6. So our first turning point, or our first stationary point, is equal to 0, 6. Next one's going to be a little harder. So we're going to go to when x is equal to 4/3. I'm going to write this out for the examiner. So we've got 2 lots of 4/3 cubed minus 4 lots of 4/3 squared plus 6. Now this is one where I certainly wouldn't work this out in my head, so I'm going to go to my calculator and work it out there. So we've got 2 open brackets fraction. Again, I'm using the 0607 calculator, but again, any Casio is fine for this process. And we want a bracket. Oh, too many brackets. Cubed, so I'm going to use this button here for cubed. Minus, let's just remind myself what it is. So it's minus 4 open brackets, 4/3 squared plus 6. Press enter, and then you'll generate your answer of 98/27. So this is where the calculator is very handy to work out these more complex calculations with fractions, and that gives me the y coordinate of the other turning point, like so. So there's the mark scheme, so you can have a quick look through and where you actually get the marks and what some of the method marks are dependent on as well. Okay, on to the next question. So again, this is very, very typical of the paper 4 and the 0580 course. They don't start necessarily with a differentiation problem. It's usually embedded in another question. So in this case, the equation is cubic, x cubed minus 4x squared plus 4x can be written in this form. Find the value of a. So cubics, generally speaking, will be written in such a way so you can factorize this quite easily. So notice they've all got a factor of x here. So we're going to take a factor of x out. What do you multiply x by to get x cubed? X squared. What do you multiply x by to get minus 4x squared? Minus 4x. What do you multiply x by to get 4x? It's just plus 4. At this point, we've got a quadratic within the bracket. So at this point, we can put this into 2 brackets. And we put an x at the front, an x at the front. And we want 2 numbers that multiply to give me 4, but add to give me minus 4. Well, that's going to be minus 2 and minus 2. And notice, because you've got two x minus 2's, this can be simplified further as x minus 2 squared. Now that's not the answer that they're looking for. The actual answer is, what's this missing value a here? And notice it's the value of 2. Now, one of the reasons they've done this in the first part is now we can now draw a very nice sketch. So if I was to solve this equation, so let me pop this over here. So x over x minus 2 all squared times x minus 2 all squared is equal to 0. Then using the null law, I know then that x must be either equal to 0 or equal to 2. However, this is a cubic. So remember that the shape of a cubic, generally speaking, looks something like this. So it crosses the axis 3 times. This is a very special cubic where it only crosses or touches the x-axis twice. So let's mark in those turning points. So we've got 0 here and 2 over here. We have a positive cubic. Notice this is an x cubed. And so we've got all the information we need to draw a good sketch. So watch carefully. We're going to go up, 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 up. We go through the point, and this is the crucial part. Because 2 is a repeated root, we're just going to touch the graph there, and then we go off. That's a little bit of a bend there. Try and make sure that's a nice smooth curve as well. Okay, so notice that I've followed the instructions of the question, where the graph meets the axes, where it meets it at 0, 0, meets at 2, 0 as well. But there is some sort of local maximum, but that's not necessary for this question. You'll see in the mark scheme, if I go forward to the mark scheme. So here's your graph. So it's going through the origin, going through 2, 0, the positive cubic, and it's the right shape as well. So you can see I pick up all 4 marks. Now comes to the differentiation part. So they take that cubic, and we want to find the equation of the tangent to the graph at x equals 4. So what that means in real English is, if I take green, x is 4 is probably up here somewhere. Okay, so if we read that off, that's 4. So basically, at that particular point, we want to find the tangent line. So the line that just touches the curve and then disappears off. So this really, really steep line. And we want to find that equation of that particular line. So the way we do this is we use some differentiation. This is where it's embedded. So first of all, we need to differentiate the function. So we get dy by dx. So remember, we take the 3, bring it to the front, reduce it by 1. So we get 3x squared. We do the same procedure here. I'm speeding up slightly now. So minus 4 times 2 is equal to minus 8. Reduce the index by 1 is 8x. And don't forget, because you've got a 4x here, we do the same procedure because this is a 1. 1 times 4 is 4. And then reduce the index by 1. That's x to the power of 0, which is just 1. So we get the function of dy by dx is equal to 3x squared minus 8x plus 4. Now at this point, we actually want to work out the gradient at the specific point. We don't want to work out turning points or anything. So we need to work out d by dx, where x is equal to 4. What does that mean in real English? Well, we're going to put 4 into this equation. So we get 3 lots of 4 squared minus 8 times 4 plus 4. Well, 4 squared is 16. 16 times 3 is 48. 8 times 4 is 32. Plus 4. And that simplifies to 20. Okay. So the gradient of that green line that I drew over here, let me just mark this in. The gradient of this line is equal to 20. So we've got that information. Now that means that the tangent line, so I'm going to write the word tangent, has the form y equals 20x plus c. And now we need to work out the y-intercept, this c. Now the only point that we know on this particular tangent line is this point here. Okay, and we know the x-coordinate is 4, but we currently don't know what the y-coordinate is. The way we can work that out is actually substitute x equals 4 into this equation. So when x is equal to 4, y is equal to 4 cubed minus 4 lots of 4 squared plus 4 times 4. That's a lot of 4s. That is definitely a lot of 4s. So we get 4 cubed is equal to 64. Well, 4 squared is 16. 16 times 4 is 64. Oh, that's nice. That cancels. And then we get 4 times 4 is 16. So when x is 4, y is 16. So this coordinate is actually 4, 16. And now we have enough information to work out c. So when x is equal to 4, y is equal to 16. You can see why this is a 7-mark question. A lot of work involved. So we've got 16 equals 20 lots of 4 plus c. So 16 is equal to 80 plus c. And then c is equal to 16 minus 80. This is really where you don't want to make a silly mistake, by the way. So 16 minus 80, that's equal to minus 64. So our final answer is equal to y equals 20x minus 64. And you'll see that agrees with the final answer at the end for all 7 marks. So just be very careful of that kind of calculation right at the end. You're going to be tired at the end of a question like this. Make sure you're accurate all the way until the end. Okay, and here's another very typical paper 4 question with differentiation integrated in there. We're going to do some work with curves. So we've got the sketch of the curve x squared plus 3x minus 4, and we need to find the coordinates of A, B, and C. Well, C is the easiest one because that is the y-intercept. So the y-intercept, remember, is just the number at the end of the quadratic, so this one here. So that's going to be 0 minus 4. So that was easier to work out. The a and b are what's known as the roots of the equation, and we work those out by taking our quadratic and making it equal to 0. So then we can actually factorize this. Of course, you can use the formula if you so wish. And the way I tend to solve these is I look for two numbers that multiply to give me minus 4, add to give me plus 3. And the numbers that seem to work here are plus 4 and minus 1. 4 minus 1 is 3. 4 times minus 1 is minus 4. I need to solve this. Well, either x minus 1 is equal to 0, so x is 1, or x plus 4 is equal to 0, and x is minus 4. So then we've got the x coordinates of the two roots. So a, is, remember, is more on the left-hand side, so that's going to be minus 4, 0. And then because this is in the positive quadrant, b is going to be 1, 0. So don't be surprised if there is something else within the differentiation question. So if they get you to work with some graphs, cubics, quadratics, etc. Make sure you're happy with those kind of questions. Now we need to differentiate our function. So we're going to work out what dy by dx is. Well, remember, take the 2. Probably sound like a broken record at this point. Bring it to the back, so we get 2x. And then if you differentiate something with just a single x, of course, we just get the number in front. So we get 2x plus 3. So let's make sure we write that in the right place. And once we've done that, then we want to find the equation of the tangent to the curve at the point 2, 6. Okay, so essentially what we're doing, if I represent this, is if we take the point 2, it's going to be up here somewhere, then we want to find this tangent line that just touches the graph and then disappears off. Obviously, it doesn't bend in the middle, a nice straight line. So what we do is we work out the gradient at x is equal to 2. That comes from this coordinate here. So I'm going to take my answer here, 2x plus 3, and replace the x with a 2. That gives me 2 times 2 is 4, 4 plus 3 is 7. So that's going to be the gradient of the tangent line. So I'm going to write this in words, like so. And therefore, this gradient, this tangent line is going to have the equation of y equals 7x plus c. We have a nice coordinate given already, which is very, very helpful. So we can actually work out the c. So when x is equal to 2, y is equal to 6. So we get 6 is equal to 7 times 2, which is going to be 14. And then to work out c, we're going to minus 14 from both sides. and that's going to give us minus 8. So our final answer is going to be y is equal to 7x minus 8. 3-mark question, and one of the reasons it's a little bit less than the previous question we looked at is they already gave us one of the points already on the tangent line. So you can check your answers, you can have a look through what I've just done. Again, typical paper 4 question. I'm really trying to give you as much exposure to 0580 differentiation questions as I can, so you're ready for lots of different situations that can arise. And we're on to yet more curve sketching. Yes, they do like putting curve sketching with differentiation. So we need to do some factorising first of all. A little bit trickier because we've got a minus x squared, but we still set this up in our 2 brackets. Notice this time I'm going to have a plus x and a minus x. But the rules still apply in terms of using the 24. So you want 2 numbers that multiply to give you 24, but minus to give me the plus 5. So if we think about that for a moment, 8 and 3 seem to work. We just need to make sure they're in the right place. So we want a plus 5x at the end, so we want our bigger number in the center, because remember when we do FOIL, x times 8 is 8x. So we'll put the 8 in here, and we'll put 3 in here. 8 times 3 is 24, so that matches. And to sort of double check what I'm doing here, I would check what's called the cross terms, so the outside and inside. Well, the outside term we get minus 3x, inside term we get 8x, 8x minus 3x is 5x. Yes, I do have the correct answer. So I'm going to pop that in, 3 plus x, 8 minus x. And this works in a similar way to how we did the previous question. First of all, C is our y-intercept, which is just the number part. So that's going to be 24. So it just wants the number this time, not the coordinate. So C is 24. And then the roots of the equation, well, we take what we just did and set it equal to 0. So that means then that 3 plus x is equal to 0. X is minus 3. Or 8 minus x is equal to 0. So x is equal to 8. So those are my 2 values of x. So the one left hand side in the negative quadrant, so that's going to be minus 3, and x is equal to 8, so that goes in there. You just make sure you've got the right letters for the right numbers. You don't want to make a silly mistake. Now, you're probably wondering, where is a differentiation? Well, here it is. We need to calculate the gradient. As soon as you see this word gradient, that should be triggering in your mind differentiation of some kind. And we need to find it at a specific point. Again, we've seen lots of questions like this now. So we're going to work out dy by dx. So 24, that's going to disappear. Notice it's in a different order. Plus 5x differentiated gives us minus 5. Just 5. And then minus x squared, be a bit careful here. The 2 comes to the back. And so we get minus 2x. So that's our gradient function. And then we're going to work out that specific function at x is equal to minus 1.5. So we get 5 minus 2 times minus 1.5. Minus 2 times minus 1.5 is positive 3. So the gradient, and that's all we need here, the gradient, not the tangent, is equal to 8. So 8 is our final answer. So you can have a look through the mark scheme and also see where you pick up your marks. Let's keep going. There are more differentiation questions yet. You wouldn't believe it, but there are. So this one is a very intimidating looking question. So you just have one big space of white, and for 6 marks, they give you an equation, a cubic this time, and you just need to work out the coordinates of the 2 turning points. This was right towards the end of one of the papers I looked at. So we use all the skills that we built up so far to work this out. The first thing we need to do is differentiate. Notice lots of different vocab that they use here. Oh, there we are. There's my pen. So this time they say turning point. So remember, that's the same as a stationary point. Be familiar with all these different words. And in order to do this, we need to work out dy by dx. So dy by dx. Again, broken record time, 3 to the back, we get 3x squared. And then we take this and bring it to the back. We get plus 16x. And then finally we differentiate 5x, which just gives us 5. And because we're looking for the turning points, we want to work it out when the gradient is equal to 0. Therefore, 3x squared plus 16x plus 5 is equal to 0. And again, you could use the quadratic formula if you're not happy with the factorizing process. Again, but this is something if you want to do a more advanced maths at A level or IB, you need to get into the habit of. So we get 3x and x. We want two numbers that multiply to give me 5. So we're going to think about 5 and 1, 1 and 5, and also the minus versions of these as well. However, these are not going to work because we want a positive here. So by doing this process of elimination, I know one of these is going to work. I want a very big number here, 16, so I need my biggest number outside, because 3x times 5x is 15x. So that leaves me here with 1x. So notice I'm doing this sort of very careful sort of building up of, okay, what makes sense here? In order to factorize, by doing this, then we say either one of the brackets is 0, so 3x plus 1 is equal to 0, 3x is equal to minus 1, x is equal to minus a third, or x plus 5 is equal to 0, x is equal to negative 5. So those are x values of the turning points or stationary points. So let's pop those in. So that's minus 5 and that's minus 1/3. Good, now we need to work out the y coordinates. So we need to go right back to the function start. And let's start with the minus 5. So when x is equal to minus 5, y is equal to minus 5, all cubed, plus 8 lots of minus 5 squared, plus 5 lots of minus 5. Okay, looks kind of tricky. Let's see if we can work this out without a calculator. So this is minus 125. Minus 5 squared is positive 25. 25 times 8 is 200. This is going to be minus 25. So I reckon this is going to be equal to 50. Yeah. So y is equal to 50 in this case. So I'll pop that in here. And we do exactly the same process, but we do it with x is equal to minus 1/3. Now you can imagine how messy this can get. So minus 1/3 cubed plus 8 minus 1/3 squared plus 5 minus 1/3. And before you think about, right, let's try and work this out in my head, I'm not going to do it. I'm going to use a calculator. So let's get the calculator out. So we've got minus 1/3. So we just need to be careful of what we're doing here. I do not want a squared. So I want minus 1/3. So minus, let's use the fraction button, 1/3. And cubed. Let's check what we're doing here. Plus 8 lots of minus 1/3. See the concentration here, can't you? You can see the concentration. And then plus 5 lots of minus 1/3. 5 lots. And this is where you just hope that somehow this all works out and you haven't done anything silly on your calculator. Let's press the big button and we get minus 22 over 27, which is the correct answer. That's good. So let's pop this in. Minus 22 over 27. And I'll pop that over here for all 6 marks. And just when you think at the end of the paper you've finished by doing this question, well, this is only part I. There is a part 2. Now we need to determine whether each of these turning points is a maximum or a minimum and give reasons for your answer. Okay, it's the only time I've actually seen a question like this. on 0,580. And the way we do this is as follows. Let's take my dy by dx over here. So dy by dx is equal to 3x squared plus 16x plus 5. And the way we work out whether it's a maximum or minimum, we take the second derivative, so d2y over dx squared. So we differentiate yet again. So we take the 2, bring it to the back. 3 times 2 is 6. X to the power of 1, which is just x. And then we differentiate 16x, which is plus 16. Remember, when we differentiate 5, that disappears. And what we're going to do now is take the x-coordinates, so the minus 5 and minus a third, and see what happens when we put it into our second derivative. So when x is equal to minus 5, d2y over dx squared is equal to 6 lots of minus 5 plus 16, which is minus 30 plus 16, which is minus 14. Which is less than 0. So if you find that when you put the x-coordinate in of the turning point and d2y over dx squared, the second derivative, is negative, this therefore means that minus 550 is a maximum. Maybe if you're introduced to this concept, it seems counterintuitive, but when the second derivative is less than 0, then minus 550 is a maximum. And you can do exactly the same process for minus a third. So then we get d2y over dx squared is equal to 6 lots of minus a third plus 16. Hopefully you're convinced this is positive. Minus 2 plus 16, which is positive 14. But the key thing, it doesn't matter what this number is, it's greater than 0, and therefore minus a third minus 22 over 27 is a minimum. Because d2y over dx squared, when putting that coordinate, or the x-coordinates, you get a positive number out. Okay, so you can look at the mark scheme and you can see where you get those marks from. I really hope you've enjoyed this series of everything to do with differentiation. If you've got any suggestions for doing a similar all-of video, then please do let me know in the comments below as well. And if you're looking to practice your probability, then check out the video right in front of you right now.